parallelogram. So since this side is parallel with that side, and you consider this diagonal as the transversal, this is a set of alternate interior angles. And this too is a set of alternate interior angles. The same thing's going to happen with your angles over here, because those are two different isosceles triangles. But for the same reason, you know that those angles were congruent. So if you got a rectangle, a lot is happening. So I didn't want to do these examples, but just know that this is the information that you will be using. So you're just plugging in values. So they're congruent, it happens to be 180, so on and so forth. Alright, let's move on to the next page. Move on to the next page. Alright. On page 217, it introduced to us an indirect proof. An indirect proof can be useful when the conclusion is a negative statement. We're not going to talk about indirect proofs right now. Let's just try to figure out regular proofs, and then maybe we'll move on to indirect. Indirect is where you make some assumption about the diagram, and then you get to a contradiction where you contradict yourself, and then so if you come to that contradiction, that means that your original statement must be false. So here it's saying, given this, try to show that it's not a rectangle. So they're going to say, well, let's assume that it is. And if it is, then all this stuff happens, and then you come to a contradiction. So, but that may. But let's just focus on normal proofs. Is that okay? Let's not move on to indirect right now. So that takes us to our next shape on page 218. Page 218 introduces us to a rhombus. And a rhombus is a parallelogram with 4 congruent sides. We just got done with the parallelogram that had 4 congruent angles. Now we're dealing with a parallelogram 4 congruent sides. I want us to answer A, B, and C. So graph this quadrilateral, and then just all you're doing is finding slope, finding distances. So on your own, please answer 10, part A, B, and C. Okay, let's talk about this. The slope of these two sides are what? 0, horizontal lines, good. And then for these two, what are they? 4/3, they're both 4/3. So we have shown that this is a parallelogram by finding the slopes. Verify that this parallelogram is a rhombus by finding the length of each side. So the length of all of the sides is what? 5 units. So these two segments, the slopes, the ones that had slopes of 0, that was pretty easy to find their lengths. You literally just had to count. If the segment is perfectly vertical or horizontal, you would just count. These you would have to use the distance formula. So distance is equal to, this is the difference in the x value squared plus the difference in the y values. Excuse me. So how are my x values changing? It's going from 1 to 3, or sorry, 1 to 4, so it's changing 3, and then 1 to 5, that's changing 4 units. So 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, square root of 25 is 5. Works out the same way with those guys over there. A test question, or a quiz question, I would give you, and I'd say, graph quadrilateral USMC with these coordinates, and then I would ask you just simply give me the best name for it. So what would be the best name for that shape? So you would have to find all the slopes and all of the distances, all the lengths of the segments, and then just analyze it. So you prove that it's a parallelogram, saying the opposite sides are parallel, but you can't stop there. You need to look at the distances. Is it just a normal parallelogram, or is it a rhombus? Okay, now it asks us in part C to find the slopes of the diagonals, segment MU and segment SC. So let's go ahead and find those. Find the slopes of the diagonals, please. Since you have it graphed, I mean, you can go back to like old school algebra 1 when you first learned what slope was. You just count it. And it's graphed, and it's a fuss with the formula. So for this segment here, segment SC, it's going to be a -2. Is that correct? Yep.
Yes.
And then for segment UM, this guy right here, it's going to be +1/2. Okay. So based off of those slopes, what can we say about the diagonals of rhombi? They are perpendicular, and that is always going to be true. It's always going to be true. So that is item D. It says, use the results in part C to complete the theorem. The diagonals of a rhombus are perpendicular. Perpendicular. Okay. Item 11. New diagram. Moving on. It says, given quadrilateral EFGH. I like how they use the acronym for the United States Marine Corps, and then like, why can't they do Navy for the next one, or Army for the next one?
No, they did that.
What?
They did that.
Yeah. It's subliminal messages.
Yeah.
Okay. Anywho, it says, list the 3 triangles that are congruent to triangle HXE. HXE. So it's this guy right here. And as we're listing these out, make sure that your letter order is correct. So we have got triangle. We got this guy right here that it's adjacent to. And so this would be FXE. One below the green one. HXG, and then the last one. FXG. So let's make sure we understand why these triangles are congruent. That's pretty important. It tells us that this is a rhombus, so I know that they have all of those sides that are congruent and corresponding. I also know that since this is a rhombus, my diagonals are perpendicular. Then from there, you would just use hypotenuse layer. Because if I wanted to prove that these 2 triangles were congruent, they share this segment. So hypotenuse layer. So all these are right triangles. And so if I wanted to prove these 2 are congruent, then I would say they have hypotenuse that are congruent, and then like you just keep doing this. So if I asked you to prove that 2 of those triangles were congruent, you would use hypotenuse. All of their hypotenuses are congruent. It's a rhombus. They're all right triangles because the diagonals of rhombi are perpendicular, and then they share the lengths. Cool. Explain why angle EFX is congruent to angle GFX. So we've got EFX, that guy, and why are these 2 congruent?
CPTC.
CPCTC. Same thing with HGX and FGX. Because if you can prove those two triangles are congruent, that means all the corresponding parts are congruent as well. So CPCTC. In a proof, you would have to state that these two triangles are congruent, so those two angles are congruent, this is CPTC. And then you'd have to say that these two triangles are congruent, so these two angles are congruent because of CPCTC. And you can continue doing that all the way around. I could say that this angle is congruent to that angle. Am I allowed to say that? Am I allowed to put one mark congruency here, one mark congruency there? Like, can I ensure that these are congruent to these?
Yes.
Yes, I can. Okay. What's happening is the diagonals are bisecting the opposite angles. Each diagonal of a rhombus bisects a pair of opposite angles. So that's part C. Each diagonal of a rhombus bisects a pair of opposite angles. So because this is a parallelogram, I know that to begin with, my opposite angles are congruent. So when you bisect it, their halves are also going to be congruent. A formal proof for the theorem in item 11 is left as an exercise. So that's one of your homework problems for this evening. List all the properties of the rhombus and begin with the properties of a parallelogram. So we're just going to list the properties of a rhombus. So what we've got is diagonals. I mean, just that theorem that we just wrote, completed each diagonal of a rhombus, bisects a pair of opposite angles. We've got the diagonals are perpendicular. We got all four sides that are congruent, plus all of the properties of the parallelogram. But the ones that are unique to a rhombus, four congruent sides, diagonals are perpendicular, the diagonals also bisect the opposite. Good? And the last shape is a square. So we're going to jump down to item 14 on page 219. And it says a square is a parallelogram with 4 right angles and 4 congruent sides. So it's a combination of a rhombus and a rectangle. So it says a square is a rectangle with what? 4 congruent sides. Just go ahead and write that. Congruent sides. And then a square is a rhombus with congruent angles, or you can write 4 right angles. So a square has all the properties of a parallelogram, all the properties of a rectangle, all the properties of a rhombus. Got them all. What?
And then it's square.
Oh, I see. Sweet. Okay. Do you remember that graph that I made? Well, it wasn't a graph, but it was like a diagram that I made, and it started off with here are the quads, and then off to the left I had kites, and then kind of in the middle I had trapezoids, and off to the right I had all those parallelograms. This right here is another way of representing the same exact information. So you have, so A is just all of your shapes. So I mean, this is all the shapes that exist out here. In this large oval, there's a certain little set of quadrilaterals. So everything in this large set is quadrilaterals. Those are the loners. That's just the kites. They have no parallel sides. Here are your trapezoids. One pair of parallel sides. And here are all your parallelograms. You get your squares. I'm sorry, you get your rectangles, rhombus, and then the hybrid of those is your squares. What's D?
D is isosceles trapezoid.
Sausage trapezoid.
Trapezoid.
Cool. All right, y'all pack up, put your calculators at home. still got 2 minutes, so you're good. You don't gotta rush out of here.